Tokyo International Airport is the largest airport in Japan, with the greatest volume of flights and passenger traffic, housing an international terminal, 2 domestic terminals, and 4 runways on its 1,450-hectare property alongside Tokyo Bay. Expanding with the growth in demand for air travel, it has developed into one of the few international airports of its scale worldwide, operating 24 hours a day. In 1955, Sanai Oil installed the first hydrant fueling system in Japan at the Tokyo International Airport, marking the beginning of its oil depot operation business. Since that time, Sanai Oil has continued to support Tokyo International Airport's massive transport system by providing the most technologically advanced oil supply equipment and the safest high-quality oil supply equipment operation. The equipment is operated and managed by a computerized total management system that operates 24 hours a day. This system provides quality and volume management for an efficient and accurate facility. Combining the expertise of people and computers, this system has never experienced an accident to this day. Sanai Oil has also acquired international standard certification for the ISO 9001 Quality Management System and the ISO 14001 Environmental Management System. The aircraft fueling facility encompasses the entire airport, starting from the jetty located on the south side of the airport all the way to the pipelines under the airport, via a fuel depot that houses storage tanks and an office building. The core of the fueling facility is the hydrant system, which is a 40-kilometer system of underground pipelines 40 centimeters in diameter that send fuel to the tarmac. This hydrant system enables large amounts of fuel to be quickly and safely transported to aircraft. Fuel is transported by tankers to the jetty adjacent to the fuel depot. Tanker fuel is discharged by connecting the fuel dischargers on the tankers to the pipelines on the jetty with loading arms. These loading arms enable fuel discharging according to the height of the ship or variations in the tide. Receiving strainers are attached to the pipelines to remove any foreign material in the fuel. Further moisture and foreign material in the fuel that passes through the receiving strainers are removed by receiving filter separators. The filtered fuel is temporarily stored in tanks. Delivered fuel passes from the storage tank through delivery strainers and is sent to delivery pumps. The motor speed of the delivery pumps that send the fuel is automatically controlled with an inverter. This maintains the required flow and optimal pressure for fueling aircraft. The fuel sent from the delivery pumps passes through delivery filter separators and is sent into the airport by pipelines. Pipelines are located under the runways, inside an approximately 700-meter-long sealed tunnel, 2.5 meters in diameter. Headers installed in the pipelines divide the network of pipelines buried under the airport into blocks. Hydrant valves connect the underground pipelines with the above-ground fueling vehicles. Hydrant dispensers are fueling vehicles that link the hydrant valves with the aircraft. These hydrant dispensers are fitted with the final filtering equipment and flow gauges, etc., that measure the amount of fuel in the aircraft. All hydrant system processes are managed by computer with a centralized system for monitoring and control. Operators constantly monitor the operation status of the system and ensure it is working normally to support safe and efficient fueling. Inspections and maintenance are constantly performed to ensure that malfunctions and failures do not occur in the equipment and devices related to the hydrant system. For the pipelines, storage tanks, and other equipment, inspections are performed in accordance with the Fire Service Act and other legislation. For electrical equipment and instruments, inspections are performed in accordance with legislation such as the Electricity Business Act. Inspections and maintenance are performed on vehicles based on the Road Trucking Vehicle Act and customer requests. The flow gauges of hydrant dispensers are also periodically inspected for accurate stock management. Sanai Oil has adopted a hydrant work management support system to enable higher efficiency and labor saving in its fueling facility administration process. This system comprehensively manages and supports processes including fuel receiving, storage, delivery, fueling, and accounting management, and as a support system, assisting in everything from quantity management to vehicle dispatching in fueling facility administration work. The system also has an online link with airline companies to load flight schedule information, including departures, arrivals, fuel orders, etc., to respond to working conditions. All the hydrant dispensers are equipped with a mobile terminal to receive updated schedules on a real-time basis. Everything from initiation of operation to issuing fueling receipts is automated, consistently enabling accurate and speedy fueling work. Since the quality of aircraft fuel requires a high level of reliability, Sanai Oil sets stringent management standards and performs quality management in order to maintain fuel quality. Fuel received from tankers is stored in tanks, and these tanks are equipped with floating suction devices. The ends of the pipes coordinate with a floating roof to ensure delivery of the clean fuel from the top layer. The fuel stored in tanks goes through a number of laboratory tests before it is delivered to aircraft to confirm that it meets the required standards. A visual inspection and moisture inspection is also performed by taking a daily fuel sample from the equipment and devices. Other strict management is performed to maintain fuel quality throughout the fueling facility, such as daily quality inspections performed on the equipment and devices themselves, and the periodic replacement of parts. When storing and handling aircraft fuel, a high-level security system that prioritizes safety is required. At Sanai Oil, we believe that maintaining safety requires all staff at work to exercise meticulous care and be aware of controls. Therefore, we have daily meetings before starting work, conduct thorough discussions before performing each operation, and also make sure to periodically conduct training exercises. We have also structured a 3-stage safety system for responding to disasters such as fire and earthquakes. The centralized monitoring and control system unifies management of the flow of fuel around the entire facility. This maintains a safe supply of fuel and also establishes a management structure that can respond quickly in the event of a disaster. As a measure to prevent static electricity, the diameter of the pipelines from the filter separators to the storage tanks is made wider to slow the flow speed and prevent the generation of static electricity. Buried pipelines have galvanic protection to prevent corrosion. The area around hydrant pits is also grounded to remove static electricity. All airport apron headers have fuel leak detection devices. We also have a system for early contact in the case of a disaster, with a network comprised of radio and paging systems, etc., established to quickly share and convey information. Emergency pump stop switches are installed in various locations, enabling fuel supplying to be stopped immediately in the case of an emergency. Fire extinguishing equipment is also installed in various locations, with foam monitor nozzles at the jetty, a fire extinguisher pump room and fire truck at the fuel depot, and various fire extinguishing equipment, including fire alarms, at each storage tank. The airport apron is also equipped with fire extinguishing equipment, enabling rapid action in the case of a disaster. In case fuel leaks into the ocean, support vessels that guide tankers are able to extend an oil boom to prevent the fuel from spreading. Emergency power supply equipment is also installed to operate the extinguisher pumps and delivery pumps in the case of a blackout. This equipment is operated by our employees to respond to disasters and prevent them from spreading. Sanai Oil has provided fuel from 1955 to the present day without accident, supporting the very foundation of air transportation. The demand for flying is expected to increase as air transport becomes even more essential in the future. We believe that Tokyo International Airport, gateway to the skies of Japan, will continue to expand its network with the world and enhance its role. Sanai Oil will continue to support the development of aviation with its high-quality services combining advanced technology that predicts the future and the power of professional employees.